Hello everyone on AI 42. We have again the Sandeep today. Sandeep, can you introduce yourself?
Sure, yeah. Thanks for having me here, Hakan and Gozia. My name is Sandeep Pawar. I'm the data analytics engineer. I work at Free Lighting in Wisconsin, United States. Uh, yeah, and I this is my second or third actually. So this is my third session here with AI 42. The first one that I did was Excel for data science. Second was the first part of this series on Power BI, doing advanced analytics in Power BI, and now we are here for the second part.
Yes, we are excited to hear what you will teach us this time about Power BI.
Yep.
Yeah, so in this one, the last time we looked at clustering and then key influencer visual. And for this one, a couple of people reached out to me after the presentation and they wanted to know more about forecasting. So in this one, we'll be looking at a very deep look at how forecasting in Power BI works, how you can use it, how you should not be using it, and I think forecasting is something that most businesses use. So I think our audience will find it very helpful in this.
Yeah, it sounds very practical and very useful. So we're really looking forward here to learning more about it. But I think before that, we will just give some more information about AI42.
Yes, sure.
So
So, the motivation for starting AI 42 comes from the recognition that there is no good starting material. And AI 42 is a strong team consisting of three Microsoft AI MVPs that strive to provide you with a valuable series of lectures that will help you jumpstart your career in data science and artificial intelligence. AI 42 aim to provide you with the necessary know-how to how that can help you dream job as long as it's related to fields of data science or machine learning. The concept is simple and involves professionals from all around the globe explaining to you underlying mathematics, statistics, probability calculation, data science, and machine learning techniques. And we'll guide you through all you have to do is follow our channel, enjoy the content every second week, filled with real life cases and experts' experience. Don't you worry, we all started from scratch and we are happy to help you build it up from there. You can always stop and rewind the videos or ask for clarification in the comment section. We hope to assist you on this wonderful journey and have you as a speaker one day. By creating cross collaboration with other organizations, we can give the best opportunities to broaden your network to the AI and data science communities. With the combination of our offer services, we would support less fortunate people and organizations that are not that recognized yet, even though they deserve it.
yes, and our organization AI42 is sponsored by Microsoft and Miles, and we're very grateful for that. But we also have some other contributors. We have Levente Pongor, who has been our graphic designer, and we also have our intro music, which is by Mina Marie. And we're also in close collaboration both with C Sharp Corner and with the global AI community, so that you can see our content also on their channels. And we would also like to thank Nicolette Toth, who has been providing us with the text material, both for our website and also for our sessions and for our advertisements. And if you want to know more about us and if you want to follow us, you can find us both on Facebook, on Instagram, and on Twitter. So please follow us so that you can get the latest news on all our events. And if you would like to see our previous sessions, they are all stored on our YouTube channel. So you can just scan the QR code here to get to the AI42 YouTube channel. And if you want to be able to register and get notified when we have new events, you can scan the other QR code to get to our meetup page.
And as well, we really value everyone. So we have a code of conduct to everyone feel welcome and acceptable in this in our events. So if you have any questions, you can go to our website to find what we have written in code of conduct.
Yes. Yeah, so I think let's go back here to Sandeep. Yes. So, Sandeep, is there anything special that you think people should think about, or should they be prepared for anything for this session?
So the session itself is very hands-on, and you should be able to follow along with me. What I've also done is, if you go to my website, powerbi.com, I've written a few blog posts about this very topic. So for some, if there is any, if you have any questions, and maybe if I gloss over any of the things in my presentation here, you can refer back to my blog there and then read about it. And if you still have any questions, just contact me, and then I'll be happy to help you.
That's nice. And then also for the viewers, we will have a Q&A session after the presentation. So please feel free to post any questions that you have in our chat or in the YouTube chat or wherever you look. So then I think we will just give the stage here to you, Sandeep.
Thank you. Hello, all. Welcome to the second session in Power BI for Advanced Analytics. My name is Sandeep Pawar. Before we get started, again, thank you, AI42, for having me for the third time. I'm really enjoying these sessions. I watched the other speakers as well. So great to be here. Hopefully, you were able to join me last time as well. So, in the first part, we looked at some of the Power BI advanced analytics things. So, for example, we started with the clustering, bivariate clustering, and multivariate clustering, how it works in Power BI, what are the limitations, and how you can use it to identify patterns in your data. We also looked at key influencer, which is a visual that's natively available in Power BI to analyze categorical or continuous data. It gives you factors or columns that are influencing a metric of your choice. We also discuss how it's done, and some of the algorithms behind it. After the last session, I some of you reached out to me, and you expressed your interest in forecasting. I was going to cover a couple of more additional things, but since there was some interest in forecasting, I thought it would be best if we could dedicate a session to forecasting itself. So today what I want to do is we will look at a practical demo of how forecasting can be done in Power BI. And at the same time, we will take a deeper look at exactly how it's done in Power BI, which is way more important. If you look at the documentation, Power BI's documentation on this topic of forecasting, you will see that there is a page, but there is not much to it. In fact, there is very little to it. It just shows you how to create the forecast, but it does not go into a lot of details. So a couple of years ago, I use forecasting a lot in my work. And forecasting is something that no matter what type of a business you are in, the company always needs it. You're always trying to forecast something, and it's probably one of the easiest and most used method of predictive modeling. So I was in a similar situation, and I could not find a whole lot. So I spent some time understanding how forecasting works in Power BI. So what I want to do now is share that with you, and hopefully you will take something meaningful out of it and use it in your own practice. Data that I'm going to use in this demo, it's a quarterly sales data for a French retailer I've included the link here, which obviously you can't see here, but I'll put it in the we'll put it in the description of the video where you can get the data, and we will look at we'll analyze the data, and we'll also see how we can use this data to create a forecast. Our business goal here is to create a forecast for the next 8 quarters. Okay, next 8 quarters, meaning for the next 2 years. In this case, in addition to just creating a forecast in Power BI, what we also want to understand is how is this forecast created in Power BI? What are some of the algorithms that are used to create these forecasts? What are the assumptions behind how Power BI creates these forecasts? Importantly, if you create a forecast, how accurate is it? How do you assess the accuracy of a forecast that Power BI creates? Can we improve it? And then when does it really work and when does it fail? And this is very important for you to understand and not just blindly create the forecast in Power BI. So let's get started. The data is actually very simple. I've already loaded it in Power BI. So let's go over here. And the data in this case, let me show you, is right over here. I'm going to pull it up on my screen. So let's go to some date, and then this is my sales. Okay. Let me, on the right hand side over here, it created a hierarchy. What I want to do is get rid of that hierarchy. So I'll click on this triangle button and then get rid of the hierarchy. So we'll go to dates only, and it will convert to dates. So we have dates now. Let me increase the font size so you can see it easily. Let's go here, font size. Okay, good enough. So it created the, we have the data here. As you can see, this is from 2012 to 2017, and the data is in quarters. So if you see the numbers here, first is the end of March, then the end of June, then end of September. So every 3 months. We can create a line chart out of this. So let's create a line chart, and you see the data over here. A few things that you want to observe here. The first thing is that when you plot something, you want to maybe first look at what is the overall trend in your data. And you can do that by clicking on here and then go to the advanced analytics pane over here and then click on the trend line. Okay, when you create a trend line here and then add, it will create a trend line which shows us it's increasing, and visually we can see that, but this just helps us put it on a chart and understand that. Next thing we want to observe is these peaks. If you see these peaks, they appear in a very regular order, right? And that's because this is a quarterly data. So it looks like it increases, or we have sales that go up based on a season end of September. So this is a quarterly data. That's why it's in regular 3 months period, and there is a nice seasonality to it. To create a forecast, it's actually very simple. To create a forecast, we select the data. We create it always works in a line chart. If you have it in a tabular or maybe a bar chart, it won't work. So it has to be a line chart. And another thing that you have to be careful about is if we go to the x-axis, so I selected that, and if you go to the format pane and then click on the x-axis, let's click on the x-axis, you will see two options here, continuous and categorical. You have to make sure that you have continuous selected. If it is categorical, the forecasting algorithm won't work. It has to be continuous. Okay, so make sure it is continuous. Then we go to the analytics pane again, and so this is the analytics pane, and right at the bottom here is the forecast option. Okay, So we will click on the forecast option, and it will give you, we'll click on add, and it will give you a bunch of different options. As soon as you click on that, it will create a forecast for you. But there are various options over here. It's first asking us what's the length of your forecast. By default, it just picked 10 points. And then confidence interval, we'll look at all these options later. But for now, I just want to create something and show you how it works. And then the seasonality. And then for now, we'll just accept the defaults. And in this case, the only thing I'm going to change is 8. Forecast length is 8, and then click on apply. And as soon as you create it, there you go. We have the forecast that's created. It doesn't show you the labels. So even if we go here and then turn on the labels, so I went here and then turn on the labels here, you'll see that it created the forecast, but it did not add any of the labels to the forecast. If you want to see the labels to the forecast that's applied to the forecast, you have to click on these 3 dots and then click on show as table. And once you show as table, let's go over here, show as table, you will see this is the sales. And then you have the forecast values that are created. And these are the forecast values. There's no way to export these out. So when you create a forecast, you see the forecast, and that's about it. Okay, so this is simple, right? I mean, you just had to click on one single button, and it created the forecast for you. Now the question is, how is this forecast created? So let's first quickly go over what I found as to how Power BI creates this forecast. And there is no official documentation on this topic, and this is just me analyzing and when reverse engineering a lot of these things, and then based on my experience, how forecasts work. I create a lot of forecasts as well, more advanced forecasts using Python and R. And so this is just based on my own experience, knowing how forecasting works. The algorithm that Power BI uses to create this forecast, it's called ETS. ETS stands for error, trend, and seasonality. There are 2 variations of that. The first is, let me make this bigger for you so it's easier to see. So the first variation of that is the algorithm is seasonal. If the data is seasonal, which in our case it is seasonal, we have quarterly seasonality, then it uses ETS AAA. And if it is non-seasonal, it uses ETS AAN. And we will look at exactly what that means, and we'll decode that. It's one of the things that I hope that you will take out of this session, exactly how understand how this ETS works at a very high level, and whether you should use Power BI forecast or not will hinge upon understanding the pros and cons, the advantages and the limitations of this ETS algorithm. If there is missing data, if there are missing data in your time series, then Power BI will do linear interpolation and then fill the missing values. We will look at that. It will detect the seasonality automatically for you. So this is one of the things that um, if you use Python or R, you have to input the seasonality value yourself. In Power BI, it detects, and that's the novelty here. It detects the seasonality for you. You don't have to enter it, and then it will create the forecast based on that identified seasonality. And then the very last thing is that it will create the forecast based on the horizon that you have selected. In our case, the horizon is 8 quarters into the future. Let's go to the next page. So exponential smoothing, we talked about over here ETS, and ETS, as I said earlier, is error, trend, and seasonality. It's an exponential class of algorithms. If you are familiar with forecasting, you might know that there are other types of forecasting algorithms. ETS is one of them. ARIMA, SARIMA, GAR, CHUBAR, and lots of other many different types of forecasting algorithms. What Power BI uses is ETS. Now, if you Google uh, the Power BI forecast and try to find what forecasting algorithm it uses, you may find some forums where it says it uses Sarima, which is not, it's completely inaccurate. So just know that Power BI uses ETS. The ETS AAN is nothing but a fancy name for single exponential smoothing class of algorithm, whereas ETS AAA is a Holt Winters method. So before I use too many jargons here, let's actually understand what that means. What is AAN? What is ETS? And what all of this has to do with it being exponential class. So I'm going to open my Excel sheet over here. The first thing that you want to understand is the concept of lag. It's very easy to understand. Lag is, let's say you have a time series like this. The lag is just, a first lag is just its first, we shift the series by one period. So it's past, that's just offset by one periodic value. So the 286, it comes down, so we lose 200. So we lost the recent past, right? Then lag 2 would be, we lose last two values. So if you see 372 is down over here. And the importance of understanding that is when you are creating a forecast, the forecasting algorithm will look at how your time series is correlated with its past. So in statistics, you know the concept of correlation, right? You take a variable x and variable y, and you find a correlation between the two. It's exactly the same thing. Instead of correlation, we calculate autocorrelation. Auto means with itself. So if we can, here we can do correl, for example, go here and then take this. And then it will tell us how this is correlated within the past. So this is negatively correlated and 0.85. So not much in this case. Where the exponential part comes in is, let's look at this chart over here. Let's understand what the exponential and what the single exponential means. So imagine this is our same quarterly data that we have. In the exponential smoothing algorithm, what we do in the algorithm is we assign a value alpha, also called as weight. We assign a weight, like in percentages, between 0 and 1, to each of the past values, to each of the lags. So let's imagine we are over here, and we want to predict the next value, right? We will look at the last value, assign the value alpha to it. That value can be 0 to 1. Let's say that value is 0.8. Okay. Then it will look at a value before that value. So that would be two quarters in the past. And then the same 0.8 value now will be 0.8 multiplied by 1 minus alpha, which will be 0.2. So if the value here was 1000, let's say, then our first value will be 0.8 multiplied by 1000, so which would be 800. If the next value here is, let's say 800, here 800, 0.8 multiplied by 0.2 is 0.16. So it will be 800 multiplied by 0.16. Okay, whatever that number comes out to be. Okay, and then we will keep doing that. So three quarters in the past, we will again take 0.8 into 1 minus alpha, which is 0.2, and a square of that, then a cube of that, and the fourth power of that, and this. If we actually plot all of these weights, so if I took 80%, 80% is this point 0.8 that we talked about, and then plot these out, you will see that these weights diminish very rapidly. So we assign zero point 0.8 value to our last quarter, then 0.16 value, 0.16 value to 2 quarters away, and then we are taking only 3% of the value 3 quarters away, and so on and so forth. And if you look at this decay, this is exponential, right? And that's where the exponential part comes in. If we were to use maybe a value like 0.25, it won't decay as much. It's decaying very linearly. If we took, let's say, zero point 0.5, for example, again, the same thing. If we take zero point 0.8, then that decay, okay, something, I messed up something over here. Yeah, let's do that. Zero point 0.5. The decay is not as much. And that's where the exponential part comes in. And this is for the single exponential part of it. Single exponential meaning there is no seasonality to it. And if there is no seasonality that's associated with it, it will use this single exponential smoothing, AAN. If there is a seasonality, it will use Holt-Winters method. And the way the Holt-Winters method works is Power BI will decompose the time series into trend, seasonality, and cycle. Trend meaning how is the long-term average? It is monotony. It could be going up or going down. There is no up and down. It can only go up or it can go down. So the red line over here is the trend. Seasonality, on the other hand, is it changes frequently and it's fixed in length. In our case, the seasonality is quarter seasonality. If you have monthly data, the seasonality would be 12. If you have a weekly data, the seasonality would be 52 because there are 52 weeks in a year. In the ETS AAA algorithm, it works exactly similar to the single exponential smoothing that we looked at. Power BI will look at the trend, it will decompose the trend, and then apply that exponential weighting that we just created. It will extract the seasonality and then again go through the same process of applying different weights. And how does it know which weight to use? Well, it's an optimization problem. It will just like a hyperparameter tuning, it will go from values, let's say 0.1 to 0.9. It will look at all the possible values, calculate an error, and whichever value gives the least error is what that alpha value is. So ETS AAA works the same way. It will decompose the time series into trend, cycle, seasonality, apply that exponential weighting average to it, and then calculate the forecast. It will add all of those up together, and then it will create a forecast. The AAA that we looked at, it means additive error, additive trend, and additive seasonality. What that means is if your data is such that the trend is linearly increasing or it could be linearly decreasing, doesn't matter. If it is linearly increasing or decreasing, it's called an additive trend. If it is increasing at a rapid pace or if it is decreasing at a rapid pace, like this shown over here, like this, or it is decreasing like this, then it's called multiplicative trend. If it is increasing, but it is increasing at a slower pace, then that means it's a damp trend. So the A stands for additive. It could be multiplicative. So ETS could be M as well, or it could be D for damp. So if it is like this, then it is increasing for sure, but it is decelerating quite a bit. Same thing with the seasonality. We won't go into it. But the thing that you have to know here is that Power BI only includes additive. It only includes the additive trend as we saw here. Uh, look at here, AAA. So it only includes additive, trend, and additive seasonality. So all these different flavors of forecasting that are available, or how a time series could be modeled as, it could be MAN, it could be AMA, so on and so forth. These are all the different combinations that are possible. But Power BI only supports AAA, the additive trend and additive seasonality, which is these two. So this is AAN because this is no seasonality, and this is AAA, so additive seasonality and additive trend. So your time series is increasing, but increasing linearly, so to speak, and same thing with your seasonality. So this is very important for you to understand that what that means, because the implication of that is, if you are working with a time series and it you plot it, and that's why I created a trend earlier. If you plot it and if you see that the trend is one of these two, the multiplicative or damp, then Power BI won't be able to capture that trend, that nonlinear trend for you. And whatever forecast is created it will create a forecast still, but the forecast won't be as accurate if you were to use the multiplicative or damped trend. In most practical cases, it's actually neither. So it's never like completely additive or completely multiplicative or completely that. It's some kind of a mixture to that, and there are things that are done like transformations, applying box cost or box cost transformation, log transform, or things like that to convert it from multiplicative to additive or from damp to additive. Damped trend, typically using the damped trend method, usually gives better forecast because there is nothing usually that just keeps on increasing. Right? There is some deceleration, there is some amount of component to that trend or seasonality where it just doesn't keep on increasing. So this is where that AAA and AAN comes in. So as we discussed earlier, this is for you. This is very critical for you to understand. So always when you get your hands on a time series, always plot it first, then and always create a trend. Unfortunately, over here it will always create a linear trend for you. But this at least gives you a good understanding if it is following a linear trend or not. If it does follow the linear trend, then it's good. Just to give you a quick example of what a multiplicative seasonality would look like, it would something look like this, where it increases, right, and then it these peaks, the distance between these peaks, it increases at a very higher rate. Okay, and that's where the multiplicative seasonality comes in. Okay, so we created that. So this ETS, is it good? It is actually. So if I blow this up a little bit here, this is from a competition called M3 competition. Usually every couple of years or so, where they share a lot of different time series and forecasting practitioners. They participate and they apply various forecasting algorithms, and a winner is announced. If we look at the M3 data and the M3 results, ETS, if you look down here, this is on the y-axis is the error, so smaller the better. ETS is actually one of the best algorithms to use. It is, in fact, as good as, and in many cases, even better than, let's say, using random forest or using RNN, the neural networks, or even CART, which is the decision tree and random forest. So ETS is actually very good. It's very versatile, and it's used in practice quite a bit for univariate time series. It's very robust as well. It's robust meaning it is very robust to the outliers. If there are any outliers in your data, it works slightly better than using an ARIMA model. And it's very easy to forecast or even on large time series data. The limitations of using ETS is that it cannot be used with high frequency data. And again, this is one of those things that you have to understand. If you get your hands on your data, and if the data is monthly or yearly, you are good. Or even it is, maybe weekly data, you're good. If the data is hourly data or daily data, and if you apply ETS algorithm to it, you will not get accurate forecasts. And the reason for that is hourly or daily forecast, it usually has multiple seasonalities in it. So imagine you have a data that shows a daily production rate for a manufacturing company. It most likely has some weekly seasonality pattern to it, or maybe monthly seasonality pattern to it. And ETS, we can only use one seasonality value. Uh, so if you have hourly or daily data, and this is one of those things that I see many Power BI practitioners make an error in this, that it they have the data and then they just use it, and then they see, hey, the forecast is just showing one single line. And the reason for that is because if it does not detect a seasonality in your data, it will switch over to that AAN algorithm, which is single exponential smoothing. Single exponential smoothing always creates a single line forecast. It will not give meaning. Let's go over here. If we were to apply a single exponential smoothing in this case, it will just be one single line, basically an extension of this trend line, because that's what AAN is. It will just extend the line out. So if your data has high frequency count in it, or it is high frequency, then don't use it. Okay. Or if it is intermittent data as well. Intermittent meaning, let's see, intermittent intermittent meaning you have something, and then no sales for few days or a few weeks, and then some other, and then and then so this is very sporadic in nature, and when you have data like that, ETS won't work either. Okay. Imputation meaning uh, if you have missing values in your data, then Power BI will just impute those missing values by interpolation. So in this case, I manually deleted some of the data. So let me put it here. And now look at this. The way this works is, let's actually go over here. I manually deleted these two values from this. And the way interpolation will work is it will take the value before and after, and then just average it and then create a value in between the two. So it will take, for example, let's go here, it will take this value plus this value and then divide it by 2. So 612. So notice the original value was 582. The interpolated value is 612. And the forecast created based on that would look something like this, which is not, it doesn't look accurate, right? So you have to understand if there are any, it's over here. Yeah. So if there are any missing values in your data, if there are missing values, then Power BI will automatically interpolate those values for you. It could also be that maybe it is the values are missing because maybe it is zero. You did not have anything to report for that period, which in that case zero, or it's not like actually missing, right? It's just that we do not have anything. Uh, in if Power BI, if you have null in that scenario, then you should replace that null with a zero value. Um, so you just keep that in mind. Again, knowing how the ETS algorithm works, we know that when we are looking at the ETS algorithm, it will assign weightage to the past value, right? So the um, if the missing value is towards the recent past, like over here or here, um, then the interpolation, if it is inaccurate, it will lead to greater inaccuracies in your forecast. If the missing values are in the distant past, because how the ETS works is it doesn't look at the past data as much, then you are safe. So so you have to understand why you have missing values in your data, and the second thing you have to understand is where the missing values are. If there are more than 40% missing values in your time series, Power BI will not create forecast any forecast at all. If the missing values are less than 40%, which is pretty generous, I think, it will use the interpolation method that we just talked about, and then create the forecast based on that. The limitations of that, obviously, that we've been talking about is, um, one big thing is that it will not give you any sort of error. If you have any missing values in your data, Power BI will just impute those for you. I wish it gave some error that, hey, I'm going to impute those missing values, and this is what it looks like. It doesn't do anything of that sort. It just imputes the missing values and then and gives you the forecast based on that. Seasonality detection, we won't go into the details of this. You can go to my blog at Power BI, and then I've written about it. But basically, the way uh, that seasonality detection works is that it will create a power spectral density plot, and then wherever is the highest peak, it will assign that as a seasonality. And it works pretty well in most situations, but sometimes it may not. And I have an example of that. So from the same M3 data that I talked about earlier, this is a monthly data, even though it does not look like this is a monthly data, but this is a monthly data for whatever an actual monthly data. If we were asked to create a forecast based on this, I mean, one thing that we can pretty much see is when you create a trend over here, it it does not look like this is a linear trend. It looks more something like this, right? So this is more like a damped trend instead of a linear trend. So that's, I guess, first indication that, okay, the ETS algorithm is not going to be as accurate. If you did not know that, and if you just created a forecast, let's go here. I'm going to go to the forecast here. Forecast. I'm going to click on add, and then down here, notice this. It created a forecast. It went up, and then it says forecast length is 10 points, and there is seasonality is auto points. So if you look at this, does it look accurate to you? There is absolutely no reason. If you look at the distance bar, we know ETS looks at the recent past. We should expect small values in here, right? But Power BI creates this forecast and it looks completely off. And the primary reason for that is it was not able to detect any seasonality pattern in it. And the reason I know that is because let's take a quick look over here. The reason I know that is when you click on this and then go to the forecast options and then expand this one out. Let me show you. Expand this one out. When you look at the point, it says years, quarters, months. It gives you all the different options, right? And then you can either select from this if you know what your seasonality is, you can select from it, or it will automatically default. Whereas if we go to this time series over here, and then let's go to the same options. Look at this. Do we get any of those things? We do not. We just get the points. So Power BI actually was not able to detect the seasonality in this case, and which is why it got confused and created this. We know this is a monthly seasonality which has seasonality number of 12. So what we will do is in over here where it says seasonality, instead of letting Power BI do it for us, we will enter seasonality of 12 and then apply. Now this looks much more realistic, doesn't it? So we have some data that tells us, or this trend tells us that it is going down. It's in downward trend, and when we input 12 as the seasonality, it now created the forecast, which intuitively, just looking at it, makes much more sense than what we had earlier. So that is another key takeaway that you should keep in mind. Like never accept what the default seasonality value. When you are creating a forecast in Power BI, always make sure that you enter the seasonality value. And it's as I mentioned, it's very easy, right? If you have monthly data, enter the seasonality as 12. If you have weekly data, the seasonality is 52. If you have yearly data, the seasonality is 1. If you have high frequency data, you should not be using Power BI's forecast because it's going to be completely inaccurate if there is a seasonality in that high frequency data. So always enter the seasonality value in your data so that you can create more accurate forecasts. Another limitation of this is this auto detection of seasonality typically works. It needs enough data to calculate the seasonality. So usually 3 to 4 times the cycles. So if your data has monthly seasonality, that would be 12 multiplied by 3 or 4, so which would be 36 or 48. So if you are creating a forecast, if your goal is to create a monthly forecast, you should have at least 3 or 4 years worth of data. If you have 2 years worth of data, you will still be able to create the forecast, but it will not be as accurate, especially when you are letting Power BI decide what the seasonality should be. How accurate is Power BI? It depends on the problem that you're trying to solve. So for the same data that I just showed you, I went through a few different things. So I created the forecast in Power BI. The error rate is 8%. If I use Azure ML's auto ML option for forecasting, it is 6%. So not much different from Power BI, honestly. If we use the AAD option, meaning damped seasonality, it's 5%. And if I use an ensemble forecast, meaning combine different forecasts together, the forecast error is only 3%. So 3% versus 8%, it all depends on your application. If it is a critical application where The difference between 3% and 8% is billions of dollars or millions of dollars for your company. Then you might be it might be worth exploring other options and not use Power BI's forecast. How do you create all these different forecasts outside of Power BI? One way is to use Azure ML. Don't have to use Azure ML, but you can use Azure ML, or you can create either the Auto ML option for forecasting in Azure ML, or you can deploy a forecasting model in Azure ML, and then get the data in Power BI and then use it. So something like this, like an architecture like this. I have a Power BI dashboard, sample Power BI dashboard. So this is based completely on getting the data in Power BI and then deploying a model in Azure ML, forecast model in Azure ML, and then getting those forecasts into Power BI, to show them to the end business users. And this is completely dynamic now. If we look at, if we select different options, it will change, it will reconcile to the right level, and then change different things. So this is completely dynamic, and you're able to create your sales and the forecasts based on that. You can also create the KPIs based on that, right? If your goal is to show it as a KPI, that what your forecast is going to be, Power BI forecast that you create over here, because you're not able to extract these forecasts out of Power BI, you will not be able to create a DAX measure on top of that. So, which is a big limitation of creating the forecast in Power BI. One interesting thing here is you can actually create, if you want to understand what sort of forecast Power BI is going to create, you can actually reverse engineer it in Excel. So if we go to Excel, actually, I have the exact same data that we are using in Power BI, okay, exact same data. And now if I select this data here, and up at the top, let's go to over here. So what I'm going to do is click on the data options, and I'm going to click on forecast sheet here. Okay, I'm going to click on the forecast sheet. And when you look at that, it will and create the forecast. Notice what it just created. It created a forecast that looks awfully similar to what we got in Power BI. And the reason for that is Excel actually uses the exact same forecasting algorithm that Power BI uses, that ETS-AAA or ETS-AAN algorithm. Um, so if you are able to actually get the data in Excel, and then create the forecast in Excel, and then maybe import that into Power BI. It will work better if you create that better than creating it in Power BI. Now, remember what we talked about, that in Power BI, if the data has to be low frequency data, like monthly, quarterly, yearly, which means you will be updating this Excel sheet every month, maybe end of every month, or every quarter, or every year, once a year, which doesn't sound too bad, right? This is for you're sacrificing automation there to get better access to the data, because now you can take this forecast and then create KPIs around that in Power BI. One thing that we have not talked about is, what is this cone? What is this gray shaded area? That is the prediction interval, or prediction interval around that forecast. Meaning, when you create a forecast, it will identify the errors, and based on those errors, It will create a 95% prediction interval around your mean forecast. So black line over here is your mean forecast, and the thicker that gray band is, the higher the uncertainty is in your forecast. Notice these two things over here. As you can see, the forecast band or the 95% prediction band here is thinner than over here. And the reason for that is, in this case, the values were imputed. So there is more error in your prediction. So that's why the band, the error band around your forecast is high. Whereas in this case, we did not have we have the full data, so it's much thinner. Many cases you want to be able to access those as well, because then it will let you create more dynamic forecasts like this, because you want to identify and quantify what those uncertainties are. In this case, this is Power BI, and this is using more dynamic forecasts, either using Excel or Azure ML, or whatever the case may be outside of Power BI. You're able to access those uncertainties and then assign the uncertainty some value, and then pass it on to your business users for decision making. So to wrap things up, here are some of the recommendations that we will quickly go over. Power BI use Power BI forecast for non-seasonal data and low frequency data. Always use clean data. If you have missing values, then impute those missing values yourself, either in your data source or in Power BI. Use anomaly detection. We didn't get to talk about that, but you can use anomaly detection in Power BI to understand if there are any outliers or anomalies in your data. Always enter the values, the seasonality values yourself, and use 3 to 4 times the seasonality value. If you're trying to predict yearly data, then use 4 years worth of data, so on and so forth. And then always keep in mind what the what are the implications of using ETS, and that will serve you very well. So hopefully you found this session helpful. I tried to make it as practical as I can. So if you have any questions, please drop it in the chat box, or reach out to me or on Twitter, and I would be happy to answer your questions. Again, thank you very much, AI42, for this opportunity, and I look forward to chatting with you after the session. Thank you.
So the question was that you were talking about that you were sharing, you were using, sorry, some data for this session, and
Sure.
if you can share that information.
Sure, yeah, I can do that. Let me. So, for those of you who want to look at the data, the best way would be if you go to my blog at Power BI, and then go to the first page, and I'm going to put it in the chat window here, and the organizers can get the data. Let me give me 1 second. Yeah. Do you see that in the chat window?
Yes.
Okay. You can
We
share
are
it
going
with.
to share it in a sec.
Yeah.
In the meantime, we have another question
Okay.
from James, who is asking, will you advise to use Power BI for advanced forecasting?
So it depends on what your goals are. And as we looked at in the presentation, if it depends on the data as well. If the data is low frequency, meaning if the data is, let's say, weekly, monthly, quarterly, or yearly, then you can use, and if there is some seasonality to it, then you can use forecasting in Power BI. And the reason for that is, as we saw, it uses the ETS algorithm, uh, in Power BI, and the ETS algorithm works with low frequency data. If you are working with high frequency data like hourly data or daily data, then ETS won't work as good. And the reason for that is when you have high frequency data, you may have more seasonality in your data, so you won't be able to capture that seasonality accurately. And I guess the second part of that is it depends on your goal as well. If the goal is to just show the forecast to your business users, then yeah, it's just more of a visualization thing. If the goal is to extract your forecast values and then forecast them and then maybe create some sort of a DAX measure, then you can do that. You'll have to do that outside of Power BI.
Thank you for your answer and for the
Mhm.
great question as well, of course. Um, so for those who are just joined us now, like in the last few minutes, and that I just wanted to mention that this session is going to be recorded and will be available on our Teams channel. So you can check out again, so you can see the session whenever you want to rewatch it. Um, do we have any more questions from the audience?
No, no more questions as I can see.
All right. Then maybe we can bring in our
Yeah,
last few.
one more question actually here. So we have a
Oh, yeah.
question here from Gabriel. He says, in your experience, would you change the confidence interval of 95%? What other parameters would you adjust?
Great question. So there is a little bit of the confidence interval here is a little bit of misnomer. And I'm not sure why Power BI chose that term confidence interval. What Power BI is actually calculating is prediction interval. And confidence interval in forecasting doesn't help you a whole lot. So the difference between confidence interval and prediction interval is that prediction interval calculates uncertainty around your mean forecast, whereas confidence interval is more of a way to uh, to calculate for your mean forecast what is the band, the confidence interval band. And in most cases, in business scenarios, we are interested in the prediction interval because it calculates the uncertainty around those mean estimates. So just one clarification there. So even though it says confidence interval, and maybe if you're reading it in a book and it says prediction interval, just know that Power BI is actually calculating prediction interval. Now, answering your question about would you change the confidence interval of 95%, that also depends on your business context. In most companies, it depends on the risk your business can take. If you want to buffer the risk, meaning you cannot take a lot of risk, then 95 you can leave it at 95% because you want to see all the capture, you want to see whatever is the uncertainty in your estimate. But in most scenarios, your company is likely it will likely want to take some risk, right? Because unless there is risk, there is no reward, and you want to see what that reward is. And in those scenarios, in most likely scenarios, you would reduce that confidence interval from 95 to 80%, and that's very typical 80-20 rule, and then you would reduce it to 80%. As far as what other parameters would you adjust, there are no parameters, at least in Power BI, that you can adjust. So the only thing that you can change here is the band around the confidence interval, which you can change it to 80%. Um, the seasonality factor is there, but that will depend on what type of seasonality you have in your data. If you're working with, let's say, monthly data, then the seasonality number is 12. If you're working with quarterly data, that seasonality number is 4, so on and so forth. And but that's not a parameter of the forecasting algorithm itself. It's just whatever it is. And the third thing there is how many data points you forget or you say ignore the past data points that you want to ignore. And in that case, we if you want to check how accurate the forecast would be. So let's imagine a case where you want to forecast for the next 4 quarters. Then you would in ignore last points, you would include four, and then see if you disregard the last 4 quarters, what would your forecast look like. So that in a way is a way for you to understand how much error there is in your forecast. Unfortunately, again, Power BI does not give you any estimate of the errors in your forecast. So that is an approximate way of understanding what it is. If you were doing it in Python or R, for example, then yes, you would be able to change the parameters. Like we saw in the presentation, instead of additive, you could go to damp, trend, and ramp seasonality, or maybe you could look at multiplicative seasonality and things like that. So in Python or R, yes, you can do that. In Power BI, unfortunately, not so much.
Well, thank you for the information. I mean, you have shared a lot of information with us lately, so
Mhm.
it's really cool to learn so much about these topics.
Sure.
So thank you a lot for being here with us again,
Mhm.
and I hope you also enjoyed it a little bit. And
Sure.
then we hope we will welcome you soon back to AI 42.
Sure. Thank you.
So with that, maybe we can have our closing notes, Håkan.
Yes, over there.
Yes, so thank you again, everyone, for joining us. It was amazing to see so many of you together with us. And we also hope that you're going to join us next time when we're going to talk about Apache Spark in Azure Databricks with Terry Mecken. So I think it's a really good idea to join us next time again. And then Laila is going to talk about Azure Machine Learning Workspace and what are the capabilities of this amazing tool. I can't wait, really, Håkan. Which is the favorite one of yours?
I'm
What-
actually looking forward to all of them. But I'm really looking forward to the Azure ML workspace and see what that entails. That sounds really interesting.
Yes, I agree with you, Håkan, totally. So yeah, so we hope to meet you again in 2 weeks on the 17th of November. And with all that, we want to say a big, big, big thank you for being with us tonight. And yeah, see you soon again.
Yeah, thank you so much. Bye bye.
Bye.